We're going to talk about adding and subtracting radicals today. The most important rule when adding and subtracting radicals is that you can't add and subtract them unless they have the same radical. So they need to have similar forms. So I could add 3 square roots of 2 plus 2 square roots of 2 because they both have the same radical. In this case, I would just have 3 plus 2, which is 5, square roots of 2. Now, if this were to be 3 square roots of 3 plus 3 square roots of 2, I could not simplify that and add it because the radicals did not match. So, if we have 4 square roots of 8 plus 3 square roots of 50, right away I see I can't add them like they are because they do not have similar radicals. But, looking at 8 and 50, I notice that I can put a perfect square into both of them. So when I do that, maybe if I simplify those, I will have a similar radical. So, let's do that. Let's first look at 4 square roots of 8. I can break the square root of 8 into a perfect square and a non-perfect square. What perfect square goes into 8? Well, going through my perfect square charts, I know that the square root of 4 times the square root of 2 can go into 8. 4 times 2 is 8, and I know 4 is a perfect square. The square root of 4 is 2, and I'm left with that square root of 2 still. Don't forget to bring down your 4, because that tags along with it. So 4 square roots of 8 can simplify into 4 times 2, which is 8 square roots of 2. Now, let's see if we can simplify 3 square roots of 50. Looking at my perfect squares chart, I know that the perfect square of 25 can go into 50 times the square root of 2. 2 times 25 is 50, and 25 is a perfect square. The square root of 25 is 5, and I'm left with that square root of 2. Don't forget to bring that 3 down again. So this can simplify into 3 times 5, which is 15 square root of 2. Now that I have them both simplified, let's see if we can add them or subtract them. In this case, we were asked to add them. So, looking at 8 square roots of 2 plus 15 square roots of 2, I wonder if I can add them. Yes, I can, because I have similar radicals. So in this case, I would just simply take 8 plus 15, which is 23, and I would still have that square root of 2. So my answer would be 23 square roots of 2. Now, once again in this problem, it's a little bit more difficult because I'm asked to add and subtract some radicals. So, looking at them, none of my radicals are the same, so I know I can't simplify them right now. Let's see if I can simplify them down to have a similar radical. So, first I'm going to look at 5 square roots of 12. I know I can break 12 down into a perfect square times a non-perfect square. I can break it into 4 times 3. 4 is a perfect square, and the square root of 4 is 2, and I'm left with that square root of 3. Remember, we have that 5, so bring it down. So 5 times 2 is 10, and I have that square root of 3. Now let's look at my next one. I have 2 square roots of 27. What perfect square can go into 27? Well, I know 9 can. 9 times 3 is 27, and 9 is a perfect square. The square root of 9 is 3, and I'm left with the square root of 3. Bringing that 2 down, I have 2 times 3, which is 6, and then I have the square root of 3 still. My last term is the square root of 128. Going through, I want to figure out what perfect square can go into 128. Now, right offhand, it might be difficult to know, so you might want to try different perfect squares that could fit in there. The biggest perfect square that'll go into 128 is 64. So I have the square root of 64 times the square root of 2. I know the square root of 64 is 8, and I'm left with the square root of 2. I have no number in front, so I have nothing to bring down. Now my last step is to see if there are some like bases that I can add them together. Well, Looking at it, I see that I need to put my addition sign there, and I have a subtraction sign there. Now I see that I have two similar bases of square roots of 3, so I can combine those two together. So 10 plus 6 is 16, and I have the square root of 3, minus 8 square root of 2. I can't simplify this anymore because my square root of 3 and square root of 2 are not similar. So my answer is just 16 square roots of 3 minus 8 square roots of 2.